This episode of the Last Week in AWS podcast edition is sponsored by our friends at Datadog, a SaaS monitoring and security platform for cloud scale infrastructure and applications. Datadog provides dashboarding, alerting, application performance monitoring, and log management in one tightly integrated platform so you can get end-to-end visibility quickly. Datadog's lightweight agent integrates seamlessly with AWS so you can start monitoring EC2, RDS, ECS, and all the other AWS services that you may or may not be using in minutes. Look at key metrics, set alerts to identify anomalies, and collaborate with your team to troubleshoot and fix issues fast. Try Datadog today with a free 14-day trial and get a t-shirt in return for installing the agent. Visit www.datadoghq.com/AWS Morning Brief to get started. That's www.datadoghq.com/AWS Morning Brief. AWS says it charges nothing for data ingress, and it is telling the truth. Now, on the face of things, that statement is extremely uninteresting. How I went about validating it, however, might prove slightly more interesting to some folks. Let's begin with how AWS data transfer pricing works. Their pricing is so ludicrously complex that I had to build a diagram a few years back to understand even part of it. This generally distills down to outbound traffic is an inscrutable yet probably unreasonably large amount of money, and inbound traffic is free. But I got to wondering just how free inbound traffic really is. The question stems from the way Transmission Control Protocol, or TCP, works. Every packet sent via TCP has the receiver send a packet acknowledging its receipt. Should that acknowledgement not arrive, the sender retransmits that packet. Those acknowledgement packets, while small, are definitionally traffic that is egressing from AWS. Are customers charged for this? If so, this may add up to something significant at scale for some workloads. After all, every AWS customer effectively takes AWS on faith when it tells you how many giga or tera or peta or exabytes of data transfer you had last month. Very few customers have an on-the-wire level of insight into their traffic volumes. Even the most aggrieved bean-counting customer with a grudge against Amazon doesn't conduct an internal audit of these things just because they're so hard to validate and verify. So obviously the solution here is for me to do an experiment or two so that other people wouldn't have to test it themselves. For my first experiment, I started with something easy, S3. It's a fully managed service. There was nothing for me to manage myself past the upload, and as a result, there was nothing for me to misconfigure to screw a test up. A few days before I ran the test, AWS helpfully spun up a new me-central-1 region in the United Arab Emirates. Since I knew I had nothing running in that region in one of my test accounts, anything that showed up in that region's bill would be a result of my experiment. I then used DD to generate 100 1-gigabyte files in a loop, filled with fresh emptiness from dev0. I don't know what Apple's done with its file systems lately, but this returned instantly, so I was convinced that it had failed. But no, it worked. Nice job, Apple engineers. I wrote a loop to iterate through those 100 files, generate a pre-signed URL for S3 for each one, then use curl to post the file to S3. I wanted to avoid using higher-level SDKs or the AWS CLI for the uploading because these things do what you would normally want them to do. They speed through large files via multi-part upload. The problem was they might also, in the process, enable compression for the transfer, and a big file completely full of zeros compresses super well. I also didn't want it to retry on failed uploads. Precision on these things is somewhat important. I let the loop run to completion, verified there weren't any errors, and then settled in to let the billing system reconcile what it thought it saw over a multi-day span. I set a reminder to check it after a long weekend, and I busied myself with other things. When the dust settled out, the bill reflected that there were 100.000000270 gigabytes of inbound data transfer. Someone at AWS is going to lose their freaking mind over those 270 bytes, but because inbound is free, that is not my problem to deal with. Outbound data transfer showed exactly 1 kilobyte of data egressing. Were it not in the free tier, I would absolutely be opening a case demanding my 11 millionths of a penny back in the form of a credit. What this demonstrates is that AWS does what it says on the tin. You're metered on the volume of the data you send it, not the protocol overhead that hits. At least so long as you use S3.
This episode is sponsored in part by our friends at Sysdig. Sysdig secures your cloud from source to run. They believe, as do I, that DevOps and security are inextricably linked. If you want to learn more about how they view this, check out their blog. It's definitely worth the read. To learn more about how they are absolutely getting it right from where I sit, visit sysdig.com and tell them that I sent you. That's SYSDIG.com. And my thanks to them for their continued support of this ridiculous nonsense.
My second experiment brought us to EC2. If I run an EC2 instance and get it to just sit there and accept traffic that I send it, data transfer is going to work slightly differently. Most traffic these days is encrypted in transit. This means that AWS has no visibility into what the payload of any given packet is. I would expect AWS to charge me for the overhead of the acknowledgement packets as a result. So for this one, I spun up an EC2 instance in the Bahrain region. I didn't SSH into it at all. I used AWS Systems Manager Session Manager. This is explicitly called out as costing nothing when used to connect to EC2 instances. So I used it to log into the node and set up a Netcat listener. Then I sent the same 100 1GB files via Netcat in a loop from my desktop, validated that there were no errors, and checked the billing system. So running an EC2 instance had a bit more interesting results, some of which I don't fully understand. The AWS bill reflected 103.639 gigabytes of inbound data transfer. Clearly, it is metering some protocol overhead in ways that it's not when submitting data to S3. Now, that 3.6% is within most reasonable levels of tolerance, but it is good to know. I was billed for 1.25 gigabytes of data transfer out during this time period, and that feels directionally correct for the relative size of acknowledgement packets. But here's where it gets strange. I can get detailed metrics in CloudWatch out of the network interface in the EC2 instance. CloudWatch shows that the instance saw 112 gigabytes of data ingress during the testing timeframe, and I could see the Systems Manager agent tossing a few megabytes back and forth for half a day as it checks in with various things, but not over 10 gigabytes of traffic in a day. And the CloudWatch metrics show that the instance emitted 1.71 gigabytes of traffic during the test window, when the billing system swears it only saw 1.25 gigabytes. So for my two experiments with data transfer, we can surmise a few things. First, AWS's CloudWatch and billing team should probably have a group lunch and introduce themselves to one another. I bet they'd have lots to talk about. Plus, the haggling over how much the tip should be would be absolutely legendary. Second, AWS basically does what I'd expect it to. None of the data volumes I saw were cause for alarm, and AWS isn't being creepy and deeply inspecting your traffic in the name of billing. And finally, every customer who pays zero attention to this aspect of data transfer pricing is absolutely correct to ignore it. But now I spent a whole bunch of time proving it.
This has been a Humble Pod production. Stay humble.